So, dear students, in today's class, I'll discuss two very important theorems for IP exam. Listen carefully. Two theorems I already discussed in the last session. So, two more theorems going to discuss in this session. F map from A to B, G map from B to C, or any three functions, then prove that H circle G circle F, H circle G circle F. So whenever you are proving a theorem, you should write very clearly examination point of view. What is given? F map from G map from B to C, or three functions. Required to prove is H circle G circle F is H circle G circle F. So here, to prove this, it is totally one function, it is the other function. To prove two functions are equal, we have to prove their domains are same first. So here H circle G means first it starts with G, G map from B to C, H map from C to D. Then H circle G map from B to D. That is G map from B to C, H map from C to D means H circle G map from B to D. Now H circle G circle F means first we should start with F. Here F which map from A to B and H circle G maps from B to D. Here H circle G circle F map from A to D. Here F map from A to B. H circle G map from B to D implies map from A to D, which implies domain of H circle G circle F is A. Right. So I found out domain of LHS. For RHS domain, H circle G circle F. First, let us find G circle F. F map from A to B, G map from B to C. G circle F means it starts with F. So G circle F will map from A to C. Now H circle G circle F means first I will take G circle F. G circle F map from A to C. H map from C to D. Then here, which implies H circle G circle F map from, which implies domain of H circle G circle F. Now, say this is one. From 1 and 2, what I can say, domain of H circle G circle F is domain of H circle. So for proving functions are one, domains must be equal and fx must be equal to g of x. These two conditions must be satisfied. So now, since domain is A, let A belongs to A, H circle G circle F of A. By definition of composite function, H of G of F of A. So I can write H circle G of F of A, which is H circle G circle F of, sorry, uh, H of G of A. I have to prove this I can write as H of G circle F of A, which is H circle G circle F of. So I prove now H circle G circle F of A is H circle of G circle F of A. Say this is 3. From 3 and 4, I can conclude that functions are equal. Right? Whenever to prove two functions are equal, you have to prove domains are equal as well as ranges are equal. Next, very, very important theorem. If F map from A to B or bijective functions, then G circle F pole inverse is F inverse circle G inverse. Here, as usual, before proving theorem, F map from A to B or bijective mappings required to prove is G circle F inverse is inverse circle. So it's not part of the theorem. I will just explain about inverse of a function separately. So don't write this in exam about inverse function. Here you take 1, 2, 3, 4. It is 1, 1 and non 2. F inverse will map from B to A. 3, 4, 1, 2. That's how inverse function is defined. Once it is bijective only, inverse will exist whose codomain and domain interchanges. Now here, to prove this is one function for us, this is like f1 function, gn function. So we have to prove that these two are equal. To prove two functions are equal, we have to prove that their domains are equal. F map from A to B, G map from B to C implies G circle F map from A to C. Here it is F, here it is G. F is from A to B, then you have G circle F will map from A to C, which implies G circle F inverse will map from C to A, which implies domain of G circle F whole inverse is C. So I found only till now domain of left hand side function. Right hand side F map from A to B, G map from B to C, G inverse will map from C to B. F inverse circle G inverse means here you have a G inverse. F inverse is this. So then here F inverse circle G inverse will be mapping from C to A, which implies domain of F inverse circle G inverse is C. So 1 and 2, domain of G circle F whole inverse is equal to domain of which is equal to C. So first part is over. Then second part, to prove functions are equal, fx must be g of x. What is the domain here? C is domain. Let us take some element. C belongs to C. What I have to prove is G circle F whole inverse of C is. So how do we prove this? F map from A to B is a function. Bijective function means obviously function. Implies for A belongs to A, for every element will have a match such that f of A is B, which implies A is equal to Fn. It is very important. You cannot write always since F is bijective, inverse exists. If inverse does not exist, then we cannot write. Similarly, for B belongs to B, there exists C belongs to capital C, such that G of B is C. Since by assuming G as function, now I can write B as since G is bijective. So here I have two relations. One is this, other is this. From these two, A is F inverse B. In place of B, G inverse C. It is F inverse circle. So I got this part. Similarly, what I have to prove is what I have to find out is G circle. F maps from A to B, G map from B to C are bijective functions. Then G circle F also bijective, which implies which implies once of all it is a function, G circle F of A will be C. That already we know it. How do I know? G circle F of A is G of F of A, G of B, G of B is C. So from this I can say A is G circle F whole inverse of C. So which is already be proved. F inverse circle G inverse of C. Let us say this is 3 from so here you have one relation. Let us say 3, this is 4. From 3 and 4 I can say domains are equal, ranges are equal, which implies functions are equal.